Good morning. We we are students from Group 6. We'd like to present to you the findings of our final project in this algebra PBL or project based learning. So let's begin. Good morning. Today I'm excited to share the remarkable progress we've made in this PBL project. From overcoming challenges to achieving milestone, our journey reflects dedication, collaboration, and a shared commitment to excellence. Let's delve into the impactful strides we've taken together. As we know, algebra is used in many areas of life, including science, engineering, finance, and everyday problem solving. For example, it is used to design bridges and buildings, to create computer programs and video games, to model economic trends and predict stock market performance, and to solve problems in physics and chemistry. Now I'd like to talk about arithmetic progression, the first part of our presentation. The general formula for the nth term of an arithmetic progression, or AP, is given by A multiplied by n is equal to A plus in bracket n minus 1 times d, where A is the first term of the arithmetic progression. This is the common difference between any two consecutive terms on the arithmetic progression. 3. N is the position of the term in the arithmetic progression, with the first terms having a position of 1, the second term having a position of 2, and so on. Okay, now I would like to talk about geometric progression. A geometric progression is a sequence of integers in which each term is formed by multiplying the one before its constant non-zero value, known as the common ratio. Each term in the progression is then added to the previous term. There are many different kinds of geometric progressions, but one of them has a ratio of 2 in common, such the sequence 2, 4, 8, 16, and 32. The following formula can be used to calculate the nth term of a geometric progression, which is A is equal to AR power of n minus 1, where the first term of the series, A, the common ratio, and the position of term in the sequence are all given. On the other hand, it is possible to determine the term sum of a finite geometric progression by applying the following formula, which is Sn is equal to A in bracket R power n, where the first term of the series, A, the common ratio, and the position of the term in the sequence are all given. On the other hand, it is possible to determine the term sum of a finite geometric progression by applying the following formula, which is Sn is equal to A r to the power of n minus 1 over r minus 1, where S stands for the sum, A for the first term in the sequence, r for the common ratio, and n for the total number of terms in the series, and represents the total numbers of terms in the sequence. The sum of an infinite geometric progression may be calculated using the formula S finite is equal to A over 1 minus r, where S represents the overall sum, A represents the first term in the series, and R represents the common ratio.
Let's discuss about the Phila table. So the Phila table, we have part A and also part B. Part A is arithmetic progression and part B is geometric progression. So for arithmetic progression, we have here is that Ruben just graduated with a degree after finishing his study in university, and he is applying a job, and he demands a job with a salary more than 3,500 per month. So Ruben got an offer from Bank Rakyat with an annual income of 50,000 a year, and also including a 5% increment from the basic salary. So Ruben, he has a plan right now. He wants to save his bank account until it reached 10,000 ringgit. So for the facts of this Phila table is that Ruben, he wants to save a big amount of money in his bank account, and secondly, he got offer from a job after he just graduated from university. And the ideas for this project is that Rubens wants to create a saving plan, and he wants to stick to it to achieve his goal, which is saving 10,000 ringgit. And the learning issue in this project is that what is the common difference between the saving in each month, and also how long will Ruben take to save 10,000 ringgit or more. So the action plan that needed to conduct is that we need to find the common difference of saving in each month, and also we need to find the first term, which is the first month of Ruben's saving to conduct his saving plan. And next we need to find the sum of saving, which means we need to find how many months will Ruben take to save total of 10,000 ringgit or more than that. So let's move on to part B. Part B we have is geometric progression. So in the year 2012, a personal care product company was built in a state. Due to the lack of information on the population in the state, the company estimate the demand for personal care product in less than 1 million in a month. The company produced about 1,125,000 products in a month for the state. Each month, the demand for the personal care product was ascending as the population of the citizen increased. So because of that, the company has to increase 12% of product production in a month to fulfill the demand. So for the facts of this project, we can know that in the year 2012, a personal care product company was established in the state, and due to lack of the information, the company estimates the demand for the mineral water is less than 1 million in a month. And next, the idea is that the demand for the personal care product is ascending as the population is increasing, and also to meet the increasing demand resulting from population growth, the company need to increase its product, which means it need to increase 12% of product every month. And the learning issue for this project is that we need to know what is the accurate information on the state's population for precise demand estimation. Also, we need to find out what specific production planning and forecasting methods does the personal care product company employ to determine the monthly increase of 12% in production, and what factors contribute to the decision-making process in response to the growing demand associated with the increasing population. And lastly, for the action plan, which is we need to make a calculation based on the question and use a trusted finance source as a reference resource.
2.0 Problem Background. Part A, Question 1. In today's society, time is money. People like Ruben, who just completed their higher education, are eager to get a job. Most of the time, they look for jobs that can afford them the highest salary to help accommodate their families reasonably well from a financial standpoint. They would also like to calculate their salary increases over the years to adequately budget, spend, and save their money. In Ruben's case, he would like to save up to 1,000 ringgit in his bank account based on the offered 50,000 annual salary from Bank Rakyat. In order to find out how long it will take for Ruben to save 10,000 ringgit in his account, the following must be carried out. A. Calculate how much money Ruben would make each month from his annual salary to find his starting income. B. Derive an equation in terms of n, where n represents the number of months for Ruben to reach 10,000 ringgit in his account, and D represents the increment of increase of his salary. C. Solve the arithmetic progression to find out how long it would take for Ruben to achieve his goal. Part B, Question 2. Due to a lack of information, a personal care product company underestimates the number of care products it would need to produce for a month. In order to help the company properly gauge the growing amount of demand for their products, we must derive an arithmetic progression from the information given. The steps are as follows. A. How many personal care products will be produced in the 10th month? B. The total personal care products in 10 years. C. Is the amount of personal care products produced in the 20th month sufficient to fulfill the demand in a state that has 5 million citizens? Prove your answer using calculation. Assume each person uses 2 care products per month.
3.0 Solution of case study. Part A, Question 1. Ruben's starting income is 50,000 divided by 12 months, which is 1,067 ringgit. Question B, which is we need to use the equation Sn equals to n divided by 2 and multiplied by 2a plus n minus 1 multiplied by d. while SN represents the total money that Ruben will save and A represents the money that Ruben will save monthly. Question C. You need to use the equation from the question B, so you will get the n equals to 10 more. Part B, question 2. Question A. By using the equation from the first term of GP, you can get the equation which is Tn equals to AR by the power of n minus 1. The answer for this question is T10 equals to 3,119,713.6. Question B. While we using the same equation, so we can get the answer really quickly, which is T120 equals to 8.09 multiplied by 10 by the power of 11. Question C. While using the same equation, which is Tn equals to AR by the power of n minus 1, we can get the answer, which is 9,689,356.9. This doesn't fulfill the demand because 5 million citizens need to use 2 care products for 1 person, so meaning they need 10 million care products to produce. While since the 9 million care product is lower than 10 million, that means the company didn't fulfill the demand of the 5 million citizens. Okay, that's all.
For discussion and conclusion, from the problem background, we now can solve the equation by using this geometric progression method. Furthermore, we are more knowledgeable enough to understand each concept of geometric sequence formula because we have used it to solve past equation before that require this exact same formula. From question 1, to find out how long Ruben needs to save up RM10,000, we need to clarify all the information that has been given, which is Ruben wants to save up RM10,000 in his account and he is offered an annual salary of RM50,000 and a 5% increment from the basic salary from Bank Rakyat. From the info we had been given, we can determine how long Ruben needs to save up RM10,000 in his bank account with the current salary of RM50,000 offered by Bank Rakyat. With this, we can use this formula to estimate how long it will take him to save RM10,000. For question 2, to estimate the demand of the product by the citizen with the population of citizens increasing, the demand for personal care is also increasing. The company didn't produce enough product due to the increasing demand. By using this formula, we can determine how many products are needed to be produced each month to fulfill the growing population demand. Here's the formula. In conclusion, geometric progression (GP) is a fundamental concept in mathematics with widespread application in various fields. Its unique property of each term being a constant multiple by the preceding one makes it a versatile tool for modeling exponential growth or decay phenomenon. Understanding the property of geometric progression allows us to analyze and predict patterns in sequence, making it an essential topic in mathematical education. Whether used in compound interest calculation, population growth projection, or signal processing, the principles of geometric progression contribute significantly to our ability to model real-world phenomena and make informed decisions.
Audio Jungle.